Hello, my name is Christopher Niles, and I'm here to help you with negative exponents. So today we'll be looking at negative exponent representations. I'm going to do some simple conversions. We'll look at negative exponents in the denominator, so what do we do with those, and then we'll convert some of those. And then finally we'll look at negative exponents in fractions, and then we'll do some simple conversions. It's a lot. The tutorial lessons are a bit longer, and what I'm going to do is I'm going to try and summarize it and give us some shortcuts at the end. Alright, let's go. There is some assumed prior knowledge, so I'm assuming that students at this point have done some work on exponents with product rule. I'm assuming that you understand the quotient rule, and I'm assuming that you have some experience with doing powers of powers, so power rules and exponents. If you haven't done that, you might need to go back and refresh those before getting into this. Alright, let's get into the first section. So we have negative exponent representations. First up, we have 2 to the power of 3, and I'm just going to convert these into numbers really quickly. So we have 2 to the power of 3 is 8. We have 2 to the power of 2 is 4. 2 to the power of 1 is 2. And then 2 to the power of 0 is, if you don't already know it, it's 1. Anything to the power of 0 is 1. How can we do this differently? Well, have a look as we go down. What's happening here is every time we go down an exponent for 2, we're dividing by 2. And then we're going to divide by 2 again. And then we're going to divide by 2 again. And then so 2 divided by 2 is 1. Now what do I do from here? Well, look how our exponents are going down by 1. So I'll draw that in red. We're going down by 1, down by 1, down by 1. And so then this pattern just continues on. It's reasonable to assume that it's going to continue to do that. So if we go down by 1, we'll be at -1. And then if we go down by 1 again, we'll be at -2. And if we go down by 1, we'll be at -3. And this can continue on infinitely. But what's happening to the number? Well, what we'll have is we have something that looks like this. We will have divide by 2 again. Well, 1 divided by 2 is 1/2. I'm not going to do decimals right now. I'll stick to fractions, and you'll see why in a moment. The next one, when we divide by 2, so half of a half is 1/4. And then when we divide by 2 again, we're at 1/8. Now, there's one thing I want to draw out here, and if we have a look at this and this and this, well, we have 1 over 2 to the power of 1. Okay, so I want to write powers at the bottom. Now 4 can be rewritten as 1 over 2 to the power of 2. And then 1 over 8, we'll have 1 over 2 to the power of 3. So I think what I want to show here is that what these negative exponents really mean is that we have 2 to that power, but the negative means it's in the denominator of a fraction. Alright, 3 to the power of 3 we already know is 27. I almost wrote a 9 there. 3 squared is 9. 3 to the power of 3 is 3. 3 to the power of 0 is 1. Now, what is this? This is going to be 1 over 3 to the power of 1, which is just 1 over 3. And here we'll have 1 over 3 to the power of 2. And then here we'll have 1 over 3 to the power of 3. Or we can write these as 1 over 3, or 1 over 9, or 1 over 27. Now, let's take the numbers away, and let's look at some letters. These ones, they'll stay the same. We'll leave those alone. This becomes a 1. We always simplify. Anything to the power of 0 gets simplified to 1. Now for these ones, we're going to use the method that we just figured out, and it's really easy. I'm just going to turn this into a fraction, and I'm going to put a to the power of 1. We don't normally write to the power of 1, so we'll just leave it as 1 over a. This one will become 1 over a to the power of 2. And then the bottom one here will become a to the power of 3. So this is how you change the representation of negative exponents. And this is what a negative exponent means. It means that whatever that term is, it's going to be in the denominator. A to the power of -2 turns into 1 over a squared. First one, example, we have x to the power of -2. We're just going to write that as 1 over x squared. Next one, we have 5 to the power of -5. So I'm going to write this as 1 over 5 to the power of 5. Next one. Whoa, we're going to go backwards this time. So now we're going to put the negative exponent in. So what we have here will be 7 to the power of -9. Means that we have 7 to the power of 9 in the denominator. Next one. Now, these ones with the number in the front, when we change out that negative exponent, we're only dealing with the x and the 4 there. We're not actually going to touch the 2. We're going to leave that alone. So if I change this to a fraction, if I write this as a fraction, we have something over 1. And what's going to happen is this term is going to go down here, like that. So we're going to leave 2 alone, and we'll go over x to the power of 4. And that's how we change that. Next one, we have 3 over f to the power of 3. Well, if I'm going to go backwards, this is going to become 3 f to the power of negative 3. Next one, 2e to the power of negative 2. So e to the negative 2, this means that we're going to change this out to the denominator, and it's going to look like this. We're going to leave 2 alone, over 3 stays the same, e to the power of 2, just like that. We have 1 over 3k to the power of e. So in order to rewrite this, to go backwards, we're going to leave the 1 and the 3 the same. And we know that that k to the power of e is going to go up to the numerator, if we were to do it that way. And we'll have k to the power of negative e. I'm going to write that up a bit higher, actually. E. And so it would look like that. Okay, so this is how we go backwards and forwards. All right, moving on to the next one, we're going to look at negative exponents in the denominator. So I'm going to start with number first, and then we're going to try and work this out for letters. We're going to change this into a division, 1 divided by 1/2. And if you remember from previous years, when we have this, we're going to go 1 times 2 over 1. Now 1 is we can write as a fraction like that, times 2 over 1 like that, and this becomes 2 over 1. All right. So what happened to that 2? Well, it seems like that 2 has traveled up to the numerator when we went through this process of dividing a fraction. Let's do another example. So we have 3 divided by 1/2. So 3 divided into halves. We'll do 3 divided by 1/2, 3 over 1 divided by 1/2, and then we'll do 3 over 1 times 2 over 1, and that's equal to 6 over 1. What ended up happening was this 2 here multiplied that term up there, like that. Okay, so we're just trying to figure out a pattern here because we need to start working with letters soon. Now, for this one, 3 divided into 2/3. So we'll start off with 3 divided by 2/3, 3 over 1 divided by 2/3, 3 over 1 times 3 over 2, and this becomes 9 over 2. Now, what happened here? Well, this 2 stayed in the denominator, and this 3 over here, like in that last problem, ended up multiplying that top number there. All right, so I think we're getting pretty close to a method for, like a shortcut for doing this quickly. This problem here, let's just give it a go. Okay, so I think that the answer, just looking at it, what we had before, it was something like this. So I'm going to do 5 times 4 over 3, and that's going to equal 20 over 3. I'm going to show you the long way, and then we'll see if that worked. So we have 5, I won't do it with that color, sorry. We'll do 5 divided by 3/4. We'll have 5 over 1 divided by 3/4. We'll have 5 over 1 times 4 over 3. And then we'll multiply our fractions through and we'll get 20 over 3. And have a look here. So what we figured out here is that there's a very fast way of doing this when we have a fraction in the denominator. Now, what we just found out before was when we had a letter to some negative exponent, we're just going to convert it by putting it into the denominator of a fraction. And if it didn't start as a fraction, I'm going to make it into a fraction like this. And so what's happening here is that this x into the negative 2 down here is going to become this fraction in the denominator. And so if you remember our little rule, what we're going to do is we're going to take that guy and we're going to multiply the numerator by that. And what we'll end up getting is, in the end, here would be our answer. We'd have 3 times x squared over 1. Or we can just write simply 3x squared. Let me go the long way and show you that this works. We have 3 divided by 1 over x squared. Then we'll have 3 times x squared over 1, which is really just 3 times x squared, and that will be 3x squared. What we're looking at here is how to simplify expressions that have a negative exponent in the denominator. And we're going to use the little rule that we figured out using numbers to make it simpler and faster, because we don't want to keep expanding these things out. So here we go again, another example. Now this can be converted into something that looks like this. We're going to leave that 4 alone, and we're going to take that and multiply the top number by that. And so what my answer should be in the end is 3x squared over 4. Next one here. You could go through the exercise of going like this, but I'm going to go back and just have a look at our previous examples and try and draw out what was happening more simply. So we had 3 over x to the negative 2, and what ended up happening was this became 3x squared. And if I wanted to, I could put that over a 1 so that it shows that the x to the power of negative 2 went up to the numerator. The other one that we did was we had 3 over 4 times x to the power of negative, let's say 3. Well, what this turns into is 3x cubed over 4. So if you have a look at this, what's happening really is that this x to the power of negative 3 goes up to the numerator, and we change the sign to positive. So for this one, let's not go through this exercise here. What we can do here in this kind of a problem is we can simply just take the s to the power of negative 2 and bring it up to the top, and we'll change out the sign, so it's s squared over 2. Let's do some simplifying with that now. Here we have 5 over x to the power of negative 4. We can quite simply just turn this into 5x to the power of 4. What happened to the fraction? Well, what would have happened is that this would have gone up here. We would have had 5x to the power of 4 over 1, but we don't really write it over 1. We just leave it as 5x to the power of 4. So here's our answer there. Easy. All right, for this one, what we'll do is we will just take the bottom bit and move that up to the numerator, and we'll have something that looks like this. 12s to the power of 4 over 1. And we won't write it over 1, we'll just write 12s to the power of 4. And that's our answer. Next one. All right, so this one's written, we have a fraction in the denominator, and so if we remember our rules from the previous sections, it looks something like this. We'll take x squared and we'll multiply the top by x squared, so x times x squared is x cubed over t, and we'll leave that be, just like that. And that is our answer. For this one, we have f to the power of negative 17 in the bottom, so what we'll do is we'll just move that to the top and change out the sign. So this becomes f to the power of 17 over 5, and we'll leave that 5 right in place. Where did the 1 go? Well, we had f to the power of 17 times 1, so we don't really write times 1, so we just have f to the power of 17, and that's our answer there. Another one. For this one, what we'll do is we will move this part here to the top and change out that sign. So we'll have, this becomes a times ab to the power of 4. It's important that those brackets stay there because what we have is ab to the power of 4. This can be simplified though because there isn't a plus or minus sign in there. So what this is going to look like, we can use the exponent rule to carry the exponent down. So a times a b to the power of 4 is going to look something like this. It'll be a times a to the power of 4 times b to the power of 4. This 4 is going to get distributed down to each term inside the bracket. Very important that you remember that this only works because there's not a plus or a minus in there. Otherwise, that wouldn't work. Now we can simplify these a's here. We have a to the power of 5, b to the power of 4, and that's the answer. All right, for negative exponents of fractions, it's actually pretty easy. What this means is, so we have 2/3 to the power of negative 1. So what does negative 1 mean? Well, it means that it's in the denominator. So it would look something like this. We'll have 1 over 2 to the power of 3, and that's to the power of 1, although we won't really write it like that. So we just have 1 2/3 there. So what this means is 1 divided by 2/3. That's an ugly 3. We have 1 divided by 2/3, and if we remember our fraction rules here, we have 1 times 3/2. And so if we just have one of those, we have 3/2. Okay, so 2/3 to the power of -1 turned into 3/2. Let's look at it with -2. So what happens if the exponent is -2? So this is what would happen. We would have 1 over 2/3 to the power of 2. Now remember, we're going to change out that negative sign to a positive when we move it down to the denominator. Well, what's 2/3 times 2/3? Because it's 2/3 squared. This will become 1 over 2/3 times 2/3 is 4/9. And then if we have 1 divided by 4/9, we will have 1 times 9/4, and so this equals 9/4. So this can become 9/4, and that's evaluated, but I want to have a look at those numbers 9 and 4. What's interesting about them? So we can say, well, actually, what 9 is 3 squared, and what 4 is 2 squared. If we remember from our last problem, it looks as if the fraction itself got flipped over. And in this one, it looks like it did get flipped over, but then the squared applied to both of those numbers like that. So let's have a look here. So now we have 2/3 to the power of -3. We can just flip over the fraction and then turn this into a +3. So we have a positive exponent now. We're not going to write that, but that's what we have. And we'll have 3 to the power of 3 in the top and 2 to the power of 3 in the bottom. And what we'll have here is 3 times 3 times 3 is 27, and 2 times 2 times 2 is 8. And that's the answer. Next one. Again, quite simply, all we're going to do is flip the fraction over. We get 4/3, and we'll change the negative exponent into a positive exponent, and then we will have 4 squared over 3 squared, which is equal to 16/9. Getting pretty fast now, aren't we? Again, I have a fraction that the whole fraction is to a negative exponent, so we'll just flip it right over, y over x to the power of +2, and then we'll just apply that square to both terms. And so this will become y squared over x squared, and that's the answer. Next one, we have, again, a fraction to a negative exponent. Quite simply, just flip over the fraction, b cubed over a squared to the power of 2, and now we're going to, this is a power to a power, so what we'll have is, and I'll do it a long way, we'll have b to the power of 3 squared over a to the power of 2 squared. Now we'll have to apply those powers. Now when you have a power to a power, you multiply, so this becomes b to, I went ahead of myself. This becomes b to the power of 6 over a to the power of 4, and that's fully simplified. A little bit harder.
Maximum effort.
A fraction here that has a negative exponent, so quite simply, first thing we're going to do is we're just going to flip that fraction over and change that exponent to a positive. So that's the first step. Now we're going to apply that squared to the term on the top and the term in the bottom. So what we'll have is 3b cubed to the power of 2 over 2a squared to the power of 2. And what will happen is that 2, the square, will apply to both of those terms, and it will apply to both of those terms. And so we have 3 squared, which is 9, and b to the power of 3 squared is b to the power of 6. 2 squared is 4, and a to the power of 2 squared is a to the power of 4, and that is our simplified answer. All right, a couple of examples. A over c to the power of -5. Quite simply, all you're going to do is flip those fractions over and convert that exponent into a positive. Now we'll apply that 5 to both of those terms, so of c to the power of 5, a to the power of 5. Next, 3b over 2c to the power of negative 2. I have a negative exponent, so I'm going to flip the fraction over, 3b, and we'll change that exponent to a positive. And then we'll have 2c squared, which is 4c squared, over 3b squared, which is 9b squared. And that's our answer. Next one. Now for this one, that power of negative 4 is going to become quite large at the end. If you can't see it, what we're going to get is like 36 to the power of 4 and 18 to the power of 4. And these are quite large numbers. So I'm looking at those two numbers and saying to myself, well, can those be simplified? So what I'm going to do is I'm going to simplify 18 over 36. Now I know that 18 is a factor of 36. And so what I'll have is 18 goes into 18 one time, so I'll have 1b squared. And 18 goes into 36 two times, so I'll have 2c squared. Now I'm not going to write that 1, I'm going to get rid of it, so I'll have b squared over 2c squared, like that. Okay, so what I've done is I've simplified it first inside the bracket to make the numbers more manageable. They're much more manageable than 18 over 36. And now I can do that rule before that we were working on. So I'm going to flip the fraction over. It's 2c squared over b squared, and all of that to the power of positive 4 now. Now, 2 to the power of 4 is 16, so we'll have 16 and c8 over b squared to the power of 4 is b8. And this is our simplified answer. Last one for this simplification. We're going to flip that fraction over, y to the power of negative 2. Actually, I've decided a different thing. I'm looking at those negative exponents in there, and I'm thinking to myself that they're going to become a little pesky for me soon. So what I'm going to do is I'm going to first simplify inside the bracket, and I know that that y to the power of negative 2 is going to go up to the numerator, and that x to the power of negative 3 is going to go to the denominator. So all I'm going to do is I'm going to put y to the power of 2 over x to the power of 3. Now I haven't flipped over the fraction yet, okay? What I did was I looked at that negative 3 there and I said, oh, that x to the power of negative 3 needs to go into the denominator. And I looked at that negative 2 in the denominator and I said, oh, that term's going to have to go into the numerator. So I just swapped those around. Now I will do a swap again. So x3 over y squared to the power of 4. And this will become x to the power of 12 over y to the power of 8. And that is the answer for that. Alright, we just did a lot in this tutorial. There was a lot of explanation. I did a lot of example problems. And so I'm going to try and summarize what we've just done and try and just summarize our shortcuts. Firstly, if you just have a term x like this, x to the power of negative 2, it just goes to the denominator and you get rid of that negative sign. So we'll have 1 over x squared. If you have a number or a letter that's also with that term, you leave that alone. So we're just going to leave that alone. And so only that x to the power of negative 2 will get changed, and so that the a stays where it was. If you have a negative exponent in the denominator, what you're going to do is you're going to bring that up to the numerator. Now this term that I've written, x squared, is a numerator, but we just didn't write it over 1. For these ones, same thing. If you have numbers or other letters there that don't have a negative exponent, you leave those alone and just keep them where they were in the problem to start with. And the only thing that we're going to move around is this term right here. And so if x to the power of negative 2, that's going to go up to the numerator, and so we'll just move it up there like that. And then we had negative exponents of fractions. It was quite simple. All we had to do was flip over the fraction and then change the exponent to a positive. And then we'll apply the square to both of these terms, and so this becomes c squared over a squared. And so that's all you had to do. That was the quick way of doing it. And if you had numbers there, be careful. You also have to apply that exponent to the numbers in this case, because all of it is to the power of negative 2. So flip the fraction over, you get 5c over 3a to the power of positive 2. 5c times 5c is 25c squared, and then we're going to square the bottom term. 3a times 3a is 9a squared. Well, this concludes the first tutorial on negative exponents. I hope this helped.